Hello children. So before starting with today's class, let us simply revise what we have learned about solid shapes. We have learned that solid shapes have faces, sides and vertices. What is a face? The surface of a solid figure, like this is one surface, this is another surface, this is another surface. Yes, even below we'll be having a surface, on the side we have a surface, and even on the back side we have a surface. So these surfaces of a solid is called as a face. Now coming to side, we all know that it is the line where two faces meet. We can see these lines, right children? These lines are called as nothing but our sides. Now coming to the vertex, vertex is the singular. If we have more than one vertex, we call them as vertices. What is the vertex? It is the point where our two sides meet. It is the point where our two sides meet. If it is a singular, we call it as a vertex. If we have more than one vertex, that means if we have more than one point, we call them as vertices. Vertices. And what are the other names that we have learned? Vertex is nothing but the corner, and side is also referred to as edge. Side is also referred to as edge for solid shape, children. Yes, these are the basics of what is a face, side and vertex of a solid shape. Now coming to how many faces, sides and vertices do these solid shapes actually have. Coming to our first one, that is cube. Faces. How many faces does it have? 1, here 2, 3. We'll be having one below, one to the side and one on the back side. In total, a cube has 6 flat faces, children. Again, as I've said, to understand the faces, sides and vertices of solid shapes, take the objects that you have at your home. For example, you can take any box. Yes, you can take a box where okay, you can take the box and count the number of faces it has, count the number of lines it has, count the number of vertices it has. So when you take such objects and count by yourself, children, it will be easier for you to understand the concept and also remember. Okay, and also to remember. Cube is nothing but it has 6 flat faces. Again, remember the word flat. What is flat? See, this is a flat. When I push the object on the ground, then it will slide. That means cube has flat faces, and all the 6 faces of the cube are flat. There are no curved faces. Yes, so our cube has 6 flat faces. Now coming to sides, how to draw a cube, children? Draw a square, draw another square on the inside like this. Now join the vertices. See, now let us count the number of lines. When we count the number of lines that we have used to draw the figure, we'll get the number of sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In total, how many lines do we have? We are having 12 lines. That means our cube has 12 sides in total. Okay, children. Again, even for this cube also, to understand the number of sides, or even when exam you are asked how many sides does a cube have. Okay, if you don't remember the answer by heart, you can draw the cube like this. Again, let us draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took us in total 12 lines to draw our cube. That means our cube has 12 sides. What does it have, children? How many sides does it have? It has 12 sides. Now coming to the vertices. Vertices are nothing but the corners. Yes, the corners where two lines meet. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So how many vertices do we are having? See, to where two corners meet, this will be a vertex. This will be a vertex. So how many vertices does a cube have? It is having 8 vertices. It is having 8 vertices, 12 sides, and how many faces, children? 6 faces. 6 flat faces. A cube has, what can we conclude about a cube? A cube has 6 flat faces, 12 sides, and then 8 vertices. And 8 vertices. If you remember these properties of cube, even the cuboid also has the same properties. For example, let us look at the number of faces that our cuboid has. It has 1, 2, 3, one below, one to the side, and one to the back side. How many? 1, 2, 3, 4, 5, 6. Even a cuboid has 6 faces, and all these faces have a flat surface. All these faces have a flat surface. So a cuboid has 6 flat faces. Just like our cube, a cuboid also has 6 flat faces. Now coming to the sides and vertices, children, again I am drawing a cuboid. So let us count the number of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, even a cuboid here is having 12 lines. We need 12 lines to draw our cuboid. That means a cuboid also has 12 sides, just like our cube. A cuboid also has 12 lines, 12 sides, just like our cube. Now coming to the next one, that is vertices, the place where two sides meet. 1, 2, 3, 4, 5, 6, 7, 8. Again, it is also having 8 vertices. Even for the cube, we had 8 vertices. Yes, so what is it? If you know about cube, if you know about the properties of a cube, what does cube have? 6 flat faces. Coming to sides, it has 12 sides, and coming to vertices, it has 8 vertices. These are the same for what? For both our cube and cuboid. Both cube and cuboid share the same properties. What are they? They have 6 flat faces, 12 sides, and then 8 vertices. Coming to cone. Now cone has one flat surface and one curved side. One flat face, one curved face, and one curved side. It has one vertex, that is apex. Our cone, children. If you take ice cream cone. Okay. Sorry. Okay, let us use the diagram that has already been given here. If you take our ice cream cone, it is having two faces. It is having two faces. What is it? One is this face, that is in the triangle shape. Yes, that is in the triangle shape. And is it a flat surface or a curved surface? It is curved. So it is having one, our cone is having one curved face, and then here below, and then here below. Yes, see, when you take a cone like this, you'll be having this. One is this flat face at the bottom, and the other is this curved face. Yes, so our cone is having two faces, one curved face and the other is a flat face. Now coming to the number of vertex. Coming to the number of vertex, it has only one vertex, that is this on the top. Can you see this pointed edge, children? Yes, that is our vertex. So our cone has one flat face, that is this, that is this here, and one curved face, and it has one vertex, children. It has one vertex. There are no sides to a cone. A cone is having only one side. one side, only one curved side. See, this 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 side is nothing but it is only one curved side. Our cone is having one flat face, one curved face, and it is having only one curved side and only one vertex. Everything is one flat face, one curved face, one curved side, and one vertex. Now coming to our cylinder. Coming to our next solid figure, that is cylinder. Now cylinder is having two flat faces and one curved face. This is a flat face on the top, and even at the bottom we have another flat face. Yes, a flat surface. So our cylinder is having two flat faces. What does our cylinder have? It is having two flat faces. Now coming to our curved face, children, it is having one curved face. This is our one curved face. So a cylinder has what? A cylinder has two flat faces, one at the top and one at the bottom, and then it has one. Coming to the sides, children, what is a side? What did we learn? Side is the line where two faces meet. Here, as we have discussed, this is a curved face and this is a flat face. Now these two are meeting here. So we have one side here, and again this curved surface, and below also will have a flat face, right? So these two are meeting here. So this is our second side. How many sides is our cylinder having? It is having two sides, and these sides are curved. See, it is a curve, it is not a straight line. Yes, both the two sides that our cylinder has are curved. So our cylinder has two curved sides. What is a side? Side is where two faces meet. Now coming to vertices, it has no vertex. The point where two or more sides meet is called as vertex. See children, what is the side here? This is one side, and below this is our other side. Are these two sides meeting anywhere? No, they are not meeting anywhere. So our cylinder does not have any vertex. So what is it? What can we say about our cylinder? A cylinder has two flat faces. What are they? One and the other at the below. Next, it has one curved surface, that is this, and it has two curved sides, 1 and 2. And coming to vertex, it has no vertices. This is about the different sides, faces, and vertexes of the solid shapes. Sphere. A sphere has one curved face, it has no sides and no vertices. See children, it has only one curved face. This is the curved face that our sphere has. Now for side, again, side is where two faces meet. Our sphere is having only one face. It is having only one face, so it has no two faces to meet. So sphere has no sides, and in the same way, as it has no sides, it has no vertices. As it has no sides, it has no vertices. Is this clear children about sphere? Sphere has only one curved face. When it comes to sides and vertices, it has no sides and vertices. Coming to open and closed figures. Imagine yourself in a situation in which you are inside a compound wall which is closed. How will you come out of the wall without help from someone? Now imagine you are inside a compound wall which is open. What are they saying? We have to imagine. That means we have to think that we are inside a compound wall. This is a compound wall. And where are we? We are inside this here. We are inside the compound wall. And now we have to come out. We have to come out without the help of anyone. Without the help of anyone. How can we come out, children? Can you find any way to come out from this compound wall? No, there is no way. Whereas, now imagine yourself being inside a compound wall which is open. As you can see here, we are having a way out. It is open. In the second situation, you can come out of the wall since it is open. Yes, this wall is not closed, it is open. So we can easily come out of the wall. Yes or no, children? As it is open, we can easily come out of the wall. The figures which have a boundary and are closed are known as closed figures. The figures which are open are known as open figures. It is very simple. Yes. For example, if we draw a figure like this which is closed, there is no way out, which is closed from all the sides. That means it is having a proper boundary. Yes, children, it is having a proper boundary and closed. Such figures are called as closed figures. When we come to the figures which are open, for example, our second one here, it is open from here. Yes, it is not completely closed. So such figures are called as open figures. The name says it all. If it is closed, it will be closed figure. If it is open, it will be a open figure. Now let us look at some figures here, group A and group B. Draw the following figures along the dotted lines and color the region enclosed by them. While tracking the figures in group A, you will come back to the starting point. What are they saying? We have to draw along the dotted line like this. We have to draw along the dotted line, and after drawing we have to color. See children, we are coloring the figure here. After drawing we have to color the figure. Now what can you observe here? What are they saying? When you are drawing, see, I am starting from this point. Okay, remember, I am starting from this point. I am drawing this diagram here. When I am ending, again I am meeting at the starting point. Yes, what can we observe in group A? While tracing the figures in group A, you will come back to the starting point. Yes or no? See, I am starting from here. Okay, I am starting from here. I am tracing, that is drawing on the dotted line. And where am I ending at? Again I am ending at the starting point. I am coming back at the starting point. Isn't it, children? This was our starting point, and again this is our ending point as well. We are coming back to where we have started. But in group B, you will not come back to the starting point. Are you able to color the region bounded by the figures in group B? Now in group B, children, again let us start tracing. We are starting from here, right? Yes, so I'll draw along the dotted line here. Now I am ending here. Is it the starting point? Am I coming back to the starting point? No. Starting point is here, but I am ending my diagram here itself. We are not coming back at the starting point. Now coming to the coloring of these diagrams. Let us trace first and then color. Okay. Now coloring. Now how will I know where to stop? Here in the group A, I had boundaries which told me that I have to draw within these limits. Now here this is open. Now I can draw or I can color everything around. Yes or no? This figure is open. It is not telling me where to stop my coloring. There is no proper boundary. So we cannot color this figure. We cannot color this figure. See children, if I start coloring, how will I know where to stop? Should I stop here, or should I go till here, or should I color everything beside it? Yes, how will I know? We cannot know. So we cannot color the figures in group B because they do not enclose any region. They are not enclosing. That means they are not closed. If this figure was closed like this, then we would have colored this part. Then we would have colored the enclosed region. But here all the figures in group B are open figures. See, there is a gap in the middle. It is not completely closed. So we cannot color the figures in group B. The figures whose ends do not meet are called open figures. These figures the figures whose ends meet are known as closed figures. Just now we have learnt about closed and open figures. What did we learn? The figures that have a boundary and are closed are known as closed figure. For example, these. Yes or no? So another way of understanding closed figure is, what is it? The figures whose ends meet are known as closed figure. Ends in the sense, this is the starting point, this is the ending point. These 2 points are meeting together. These 2 points are the same, they are meeting. So this will be called as a closed figure. Endings. The endings or the ends meet. So it is called as a closed figure. Whereas if we observe the figures in group B, children, this is our starting point, this is our ending point. These 2 ends do not meet each other. These 2 ends do not meet. So these figures are called as open figures. The ends do not meet here. So these are called as open figures. So what is another definition that we have learned? The figures whose ends meet are known as closed figures, and the figures whose ends do not meet are called as open figures. And the region enclosed by the figure is called its interior. What are they saying? The region enclosed by the figure. Enclosed means this is a closed figure. Yes or no? Yes. So we are having some area inside the figure. We are having an area inside the figure that is enclosed, closed by the boundaries of the figure. So such region is called as interior. In means inside. Inside the figure, whatever area we have inside the figure, it is called as the interior of the figure. It is called as the what, children? Interior of the figure. Now here the figures in group A are closed figures and the figures in group B are open figures. Yes, we know these figures in group A are closed, and the figures in group B do not for the figures in group B, the ends do not meet, hence they are called as open figures, whereas for group A we call them as closed figures. Coming to exercise, children, count the number of faces, sides and vertices of different solid shapes given below. One example has been done for you. So what are they saying here? Yes, for the different solid shapes we have to write the number of vertices, sides and faces. The side for cube it is already given, and as we have learned, both cube and cuboid share the same properties. So even for cuboid the number of vertices will be 8, the number of sides 12 and the number of faces 6. Now coming to cone, children, how many vertices does cone have? Cone has only one vertex. Number of sides, it has one side, one curved side. Number of faces, it has two faces, one curved and one flat surface. Wait a minute. This is our cone, yes. So this is our flat curved surface and this is our flat surface, and these two faces are meeting here. So this line becomes our side. This line becomes our side, children. So cone has one side, one vertex and two faces. Coming to sphere, how many vertices does sphere have? 0. Number of sides are also 0. The only thing our sphere has is it has one curved face. It has one curved face. Now moving on to cylinder. How many vertices? Cylinder has how many vertices, children? Let us check. Yes, it has no vertices. Yes, that is what. Our cylinder has no vertex. Cylinder has no vertices. Coming to number of sides, cylinder has 2 sides, and coming to number of faces, cylinder has 3 faces. What are they? 2 flat faces and 1 curved face. So this is one side and this is one side. So our cylinder has 0 vertices, 2 sides and 3 faces, children. I hope this is clear. Now count and write the number of faces, sides and vertices for the following. The first object is, what is this? It is in the shape of a cube. So for cube, what are the properties, children? It has 8 vertices, 12 sides and 6 faces. Next we are having apple. Apple is in the shape of a sphere. Sphere has only one face. It has 0 vertices and also 0 sides. Now coming to the third one, it is a candle. Candle is in the shape of a cylinder. So for cylinder, what do we have? We have 0 vertices, 2 sides and 3 faces. Next we are having a lunch box. Lunch box is in the shape of a cuboid. So what does cuboid have? Number of vertices is equal to 8. Number of sides is equal to 12. And number of faces is equal to 6. Next we have a party hat that is in the shape of a cone. What does cone have, children? Cone has one vertex, it has 2 faces and 1 side. And the sixth object is a sphere. Again, it has only one face. It has 0 vertices and 0 sides. Now identify the closed figures and color the interiors. Now from these 5 figures, what are the closed figures, children? A, B and D are the closed figures. See, for E, here it is open, and even for C it is a open figure. So A, B and D are our closed figures. So let us color the interiors. Coloring them. And that's all for today, children. What did we learn today? We learned about the number of faces, vertices and sides of different solid shapes. And apart from that, we have learned what is called as a closed figure and what is called as an open figure.